Welcome to Olympian Water Testing, giving you the best in water analysis. Today we are looking at Publishing Journal, the removal of ammonia, arsenic, iron, and manganese by biological treatment from a small Iowa drinking water system. So what did they do here? Although it's not regulated in the United States, drinking water, ammonia, has the potential to increase chlorine consumption and cause nitrification problems in the distribution system. Many groundwaters with elevated ammonia are also contaminated with inorganic analytes such as arsenic, iron, and manganese, all which are primary or secondary maximum containment levels. So we talk a lot about these heavy metals as well, and that they are potentially dangerous. Arsenic more so than iron, but still, even in high concentrations, iron can cause problems. The objective of this work was to demonstrate the effectiveness of an innovative biological process to simultaneously remove the ammonia, 2 milligrams per liter, and the arsenic, iron, and manganese from a groundwater source in Iowa. The biological treatment system consisted of an aeration contactor, followed by a conventional granular media filter. And the orophosphate was also added as a biological nutrient at 0.3 milligrams per liter. Ammonium, manganese, and iron were consistently reduced through the pilot system by 98 to 99%. Complete oxidization of ammonia to nitrate was observed, and no nitrate was released, and the arsenic was consistently removed to below 10 MCl. Ammonia was oxidized by the ammonia and the nitrate oxidizing bacteria, and arsenic by the bacteria, which was converted as AS111 in the source water to more readily removable ASV. Iron was presumably oxidized by oxygen during aeration, although some biologically assisted oxidization could not be ruled out. AS-bound iron particles were removed in the filter, resulting in more effective arsenic reduction. And a surprising treatment benefit was the effective manganese reduction, the mechanism of which was not so clear, but was attributed to biologically assisted oxidization of Mn, while system accumulation time was necessary to achieve desired ammonia and manganese reductions. Acceptable arsenic and iron reductions were absorbed shortly after the startup. And we can actually see this a little bit clearer here with the pump, the sand, the gravel, contactor, the fiber. We can see the upflow regulation and the source water here, which is quite a neat invention. It was able to remove multiple things, as we see: arsenic, which is a dangerous heavy metal; iron, which is not as dangerous but can cause problems in higher amounts; and ammonia. So this is a great little invention that was able to do a lot of progress. That being said, how do you know if you have arsenic? How do you know if you have too much iron, ammonia, manganese, or any other contaminants? You have to test your water. That's why it's always a good idea to periodically test your water for high levels of these contaminants.